Hi guys, it's Mr. Colvin, and today's video is about the distance formula. So we're going to be talking about how to find the distance between the two endpoints of a line segment. So let's start by making ourselves a little line segment. So I'm going to draw a little line segment like so. Oh, that's good. We'll do it from there to there. All right, and all right. So there's my line segment. Here's my two endpoints, there and there. So the first thing I need to do is I need to write down the coordinates of the two endpoints. So the endpoint of this segment is -5, 2, and the endpoint of this segment is 4, 5. All right, great. Now, I'm going to apply the distance formula to find the length of this line segment, but before I do that, I want to explain where does this formula come from. Well, if I draw in some other lines, like so, we see that I have a right triangle, okay? And the line segment that I'm dealing with is the hypotenuse of this right triangle. Well, how do I find the two legs of the right triangle? Well, that's actually pretty simple, because this leg right here is a distance on the x-axis. It's the difference between the two x-coordinates. So I have -5 and I have 4, and the difference between them is 4. Let's try that again. 4 minus -5 equals 9. Okay? And then here, on the y-axis, this is the difference in the y-coordinates. So this would be my y-coordinate here is 2, and my y-coordinate here is 5. So this is 5 minus 2, which is 3. Okay. So I have a right triangle with legs 9 and 3. And I know that in order to find the hypotenuse, I can apply the Pythagorean theorem. So I'm going to say a squared plus b squared equals c squared. In this case, 9 squared plus 3 squared equals c squared. So 81 plus 9 equals c squared. And then I get 90 equals c squared. And I take the square root. So I get square root of 90 equals c. And if I simplify that, remember when we did simplifying radicals, I can do this as root 9 times root 10, because 90 is 9 times 10. And then this gives me 3 square root 10, because 10 is square free. Great. Well, when I use the distance formula, all I'm doing is taking those steps I just did and making them generic. Okay, so I'm abstracting them. So I'm going to label my coordinates x1, y1, and x2, y2. Well, what did I do? I took the difference from x2 to x1, and then I squared it. I took the difference from y2 to y1, and then squared it. And then after I did all that computation, I took the square root. So this is the distance formula right here. x2 minus x1 squared plus y2 minus y1 squared, and then I take the square root of that whole thing in order to find the distance. So now we're going to see how this is going to save me some time when I do example number 2. Okay, that looks like some nice points right there. Let's use those. All right. So here we go. And I have the point 3 comma -8. And I have my second point here, which is 9 comma 1. Okay, and I'm going to erase that so that I have a little bit more room. Erase, erase, erase. More room. All right. So again, oops, pen is helpful. x1, y1, x2, y2. Great. All right, so now I'm just going to plug this into my formula. So, using the distance formula, square root of x2 minus x1 squared plus y2 minus y1 squared. And I'm taking the square root of that whole thing. Alrighty. Square root of 9 minus 3 is 6. 1 minus negative 8 is 9. Oops, I forgot a parentheses there. My bad. Okay. So I get square root of 36 plus 81, which is the square root of 117. And if I look, I can see that 9 goes into 117. So this is root 9 times root 13, which is 3 root 13. Okay, so that is my answer for that one. Okay, so the length of this segment from here to here is 3 root 13. All right, now it's time for you to do an example on your own. So I'm going to erase all this and give you another example, and you're going to do it on your own, and then we'll come back and see if you got it. All right, so spray bottle. I can't find the spray bottle, so eraser. All right, we're back. Sorry about that. There's a little announcement going on in the background, and hopefully that didn't spoil the whole video. All right, so let's do one last example. Or you're going to do one more example. So after I draw this, you're going to pause the video and hopefully solve for this on your own. So we'll go from here to there. And, that's that. All right, so here's my 2 points. And I want you to find the length of this line segment using the distance formula. So pause the video, work it out on your own, and then we'll come back and see how you did. Okay, at this point you should have solved for the length of this, so let's see what's going on. So first I need my coordinates. This is -1, -3. And this is at 8, 1. Alright, and I'm going to label this x1, y1, x2, y2. And now I'm ready to plug into the distance formula. So x2 minus x1 squared plus y2 minus y1. All right, so I have 9 squared plus 4 squared, and that gives me 81 plus 16, which gives me square root of 97, and since 97 is square free, there is no simplification I can do with that, so that is my answer for the length of this line segment. This is root 97, which is, a little bit under 10. So you can also use the calculator to calculate a decimal approximation. So, moral of the story is, this is the distance formula. Know it, love it, use it, and know that it's based on the Pythagorean theorem, and that's why it works. So we're going to do some practice problems with this in class tomorrow. Make sure you answer the mastery question. To prove that you watched the video, put code word Pythagorean in your notes. That will tell me that you actually watched the video. So, hope this helped you understand the distance formula, and I will see you all tomorrow.